Hello everyone. So this video I'm going to talk about ordinary differential equations, which is one of the topic that I learned in this semester regarding to the intermediate calculus taught by Dr. Habibullah Ahadullah, and my name is Xian, entry number 292083. So now may we proceed. So ordinary differential equations are mathematical expressions that describe how one variable changes with respect to another. They are used to model a variety of real-world phenomena, from population growth, chemical reactions, and so on. In this presentation, we will explore the world of ODFs and their applications. So, what are their applications? So, the first one, human population. OD is very important to facilitate on human population growth. We will know that what is the future birth rate for human, and also what is the death rate caused by certain factors, including COVID-19 or any other factors. Electric circuit is also one of the applications of ODEs because ODEs help us to find the resistance of each component so that we can know when and where each component should react and have the resistance needed, so that things like the display brightness can be adjusted to the liking of us. Next is speed. Speed is important application of ODEs because ODEs help us to know when, at what point, at what time, and at what place speed and acceleration will reach its max or reach a certain level of dangerous, so that we can prepare for the precautions needed for our vehicles. Next, chemistry is important applications of ODEs because ODEs help us to determine the bond strength between atoms, so that chemists can formulate chemical formulas which is safe and usable for our daily use. Next is motion and directions. Motion and directions often predicted by ODEs and it is very important because we'll know when the objects will intervene each other and the effect of it. And lastly, thermodynamics. Thermodynamics help us to understand the relation between hot and cold and how the heat energy flow between the two, so that we can know how it affects our environment and how we can bring changes to our environment. Next, we'll go to the theories and laws. So first order ODEs involve derivatives of a single variable. It can be solved using a variety of techniques, includes separation of variables, integrating factors, and exact equations. Next, second order ODEs. They involve derivatives of two variables. They are often used to model physical phenomena such as motion and oscillations. Common techniques for solving second-order ODEs includes finding characteristic equations using power series solution. Next is higher-order ODEs. They involve derivatives of three or more variables. They can be used to model complex physical phenomena such as fluid dynamics and electromagnetism. Solving higher order ODEs often involves finding general solutions and applying boundary conditions. Numerical methods is suggested for solving them too. Now we'll go to the notations and terminologies. It is important for us to know about the notation of differentiation, integral, and order order and degree of the differential equation. So the right side here on the slide is the type of derivative notations that you will find when solving the problem of differential equation. On the right hand side, right upper corner there, you will find the explanation about the notation of integration. And for the right bottom corner, you will find the what is order and what is degree in a differential equation. So we'll proceed to an example so that we can further clarify what is ODEs. So for look at this example, let y be your age, x be your brother's age, and it can be the change of your age based on your brother's age can be represented by dy dx equals to 1, where when your age plus 1 and when your brother's age plus 1. So we solve this differential equation by applying the steps from above, and we will find that it will be a function which is y equals to x plus c. C is how much you are older than your brother. So let it be that you are older than your brother for 2 years. So C equals to 2. Now your brother's friends know that he is 9 years old, which means your brother is 9 years old. So they can know your age by applying the formula above. Y equals to 9 plus 2 and your age is 11 years old. So we'll proceed to a better example to explain in our real lives, because this example is pretty simple and ODEs actually can do more than that. So let it be that growth rate of a population is 0.9% and dp equals to 0.9 times p. This is the differential equation that represents the growth rate. So let p equals to number of population and t equals to the time in years. Initial population is given that the region of this population is 1,000,000, and how much does the population grow into after 10 years. So now we rewrite the equation down, which is dp over dt equals to 0.9p, and then we solve it using the steps above. This 1 over p dp equals to 0.9 dt, and then integrate it. We'll find that it is equals to ln p equals to 0.9 t plus c, and then we'll find that the final equation equals to p equals to a e 0.9 t, where a is actually equals to t power of c. So by putting the initial condition into it, we will find out that a equals to 1,000,000. So we substitute a into second equation, and then we set that we find when t equals to 10, how much does the population size is. So the final answer is shown at here, which is 810,308,392.8. This one will shows that the force and the weight are changing when the power lifter lift the chains. This one shows the one of the hot topic, which is coronavirus. So this one shows the susceptible, infected, and recover, and their rates. You can see that susceptible rate plus infected rate plus recovered rate equals to 0, and their represented differential equations are shown above. These are all the applications in life for ODEs, and they are very much useful for us to prevent future disasters to happen. So conclusion, ODs are a powerful tool for modeling a wide range of physical and mathematic phenomena, from the first order growth problems to higher order fluid dynamics. ODs can be for us to gain insights to complex system. By understanding the techniques for solving ODs, we will get a better understanding to the world around us. So that's it. Thank you.